Next topic is physical property of arenes. First point in the physical property, that is physical state, color and smell. Benzene and its higher homology up to 8 carbon are colorless liquid, whereas higher member of arenes are solid having characteristic smell. Example, naphthalene balls. We use naphthalene ball because of their unique smell and moth repelling property. Next physical property is combustion. Because of the higher carbon content is present in the arenes, they are combusted with shooty flame. It is because of the higher carbon content. Next physical property of arenes is solubility. Because of their larger size, because of their larger hydrophobic portion, they are soluble in organic solvent. Next physical property is boiling point and melting point. Boiling point is dependent upon the molecular mass. Greater will be the molecular mass, greater will be the van der Waals forces, then greater will be the boiling point. Melting point is also dependent upon the molecular mass of the arenes, but it is also dependent upon the packing. Greater will be the symmetry of the arene, greater will be its packing, then greater will be the melting point. Example, in the case of ortho and meta, the packing efficiency will be less, whereas in the case of para, the packing will be more efficient, because in the case of para isomer, because of the symmetry of this para molecule will much more efficiently pack in the crystal lattice. Because of that, the melting point of this para molecule will be much more higher in comparison to this is ortho and this is meta. Next class of compound which is also coming under the aromatic compound are polycyclic compound. In the polycyclic system, there is presence of fused benzene ring is there. Example, naphthalene and anthracene. We know that in the case of naphthalene, the structure of naphthalene is, this is naphthalene. In this there are two benzene ring which are fused. So this is also coming under the aromatic compound because it is following 4n+2 pi electron system. It is following 4n+2 pi electron system. So in this case there are 5 pi bonds, it means there are 10 pi electrons. So what is happening? It is following Huckel's rule. So if we put the value of n2, so what is happening there? 2 4 ja 8 plus 2, it means there are 10 pi electron system. So 10 pi electron system is present. So because of that, it is aromatic hydrocarbon. Next is anthracene. In anthracene there are 3 benzene ring which are fused. So if we represent the pi bond position, so what is happening in this case? So how many pi electrons are there in this case? 1, 2, 3, 4, 5, 6, 7. 7 pi electron system. So if 7 pi electrons, so it is following Huckel's rule. Because of that, what is happening? 4n+2 pi electron system. So if the value of n is 3, so what is happening? 4 3 ja 12. 12 plus 2, so it means there are 14 pi electrons. In this case there are 7 pi bond, and we know that each pi bond is formed by the 2 pi electron. So the total number of pi electron which are present in this case are 14. So it is following this rule, because in this case when the value of n is 3, then the number of pi electron which are coming is 14 pi electron. So it is following aromaticity. So this is aromatic hydrocarbon. Second, in the case of heterocyclic system, they are also following aromaticity. So what is happening in this case? Example, pyridine. Nitrogen is also having one lone pair. So this is pyridine. Next example, furan. This is furan. In this there is heteroatom, that is oxygen, and we know that in the case of oxygen there are 2 lone pairs and 2 bi bonds are present. Next system, thiophene. This is thiophene. In this heteroatom is sulfur, and there are 2 pi bonds are present, and we know that in the case of sulfur there are 2 lone pairs. Next is pyrrole. This is pyrrole. In this case, there are two pi bonds and one lone pair which is present in this nitrogen. So what is happening? Let's see these compounds are aromatic or not. So this is pyridine. What is happening in this case? There are three pi bonds. It means there are 6 pi electron because each pi bond is formed by the 2 electron. So it is following 4n plus 2 pi electron rule. So in this case the value of n is 1. So the total number of pi electron is coming 6 pi electrons. This lone pair is not contributing towards the aromaticity of the compound. It means this lone pair is no role towards the aromaticity. It is not following aromatic sextet. So what is happening? Why it is not contributing towards the aromaticity? Because this lone pair of nitrogen is present in the hybridized orbital of nitrogen. So what is happening in this case? There are 3 hybridized p orbital. One hybridized p orbital is bonded with this carbon. One hybridized p orbital is forming sigma bond with this carbon, and one hybridized p orbital is having lone pair of this nitrogen, whereas one unhybridized p orbital of this nitrogen is forming pi bond with the next carbon. So what is happening? There are 3 hybridized p orbital which are present in the nitrogen. This nitrogen is sp2 hybridized because in this case there is one s orbital and 2 p orbital. So these 3 orbitals are hybridized orbital. So these are sp2 hybridized orbital of nitrogen which are present in the same plane. These are present in the same plane. These 3 orbital of nitrogen are present in the same plane, similarly like the carbon. So what is happening in this case? And one unhybridized p orbital of this nitrogen which is present perpendicular to the plane of these hybridized orbital. So both the lobes of this unhybridized p orbital is representing because it is forming pi bond with the next carbon. So what is happening in this case? In this case there is one electron is present in this p orbital of nitrogen, one electron in hybridized orbital of this nitrogen, one electron in this hybridized orbital of this nitrogen, and there are 2 electrons present in one of the hybridized orbital of this nitrogen which is a lone pair of this nitrogen. So that is present in the one of the hybridized orbital. So what is happening? Similarly like carbon is also having 3 hybridized orbital and one unhybridized orbital which is forming pi bond. So what is happening in this case? Carbon, one hybridized orbital is overlapping with this hybridized orbital of the nitrogen. So there is pairing is taking place. Because of that, this is first sigma bond which is formed between the nitrogen and the carbon. This is sp2 sigma bond. So this is formed. Next there are 2 more hybridized p orbital of this carbon. This hybridized p orbital is also having 1 electron. This hybridized p orbital is also having 1 electron. This is forming bond with the hydrogen. So what is happening? There is one hydrogen. So this is forming bond with the hydrogen. So pairing is taking place, whereas this carbon is forming sigma bond with the next carbon. So what is happening? Forming sigma bond with the next carbon. So next carbon hybridized p orbital is this, due to which there is pairing is taking place. So what is happening? It is represented like this. So these are the hybridized p orbital of the next carbon, and there is also perpendicular p orbital is present in that carbon. So what is happening in this case? So these are the 3 hybridized p orbital of this carbon and one perpendicular p orbital which is unhybridized p orbital. This is unhybridized p orbital in which there is 1 electron. So what is happening? There is pairing is taking place. from both sides, both lobes of these p orbitals are overlapping. Weak overlapping is taking place. Because of that, there is a pi bond formation, and this is sp2 pi bond. So by the help of this molecular orbital diagram, it is understood that this lone pair of nitrogen is present in one of the p orbital. So this is one present in one of the p orbital which is present in the plane. So if it is present in the plane, then it will not be involved in the aromaticity. It is not participating in aromaticity. It is not participating in conjugation. Because of that, it is present in the plane. Whereas the orbital which are perpendicular to the plane is participating in delocalization of pi electron, that is aromaticity. So for aromaticity, there should be delocalization of pi electrons are there, and these pi electrons are perpendicular to the plane of the molecule. So in the case of nitrogen, this lone pair is present in the plane. So it is perpendicular to the unhybridized p orbital, that is pi electrons. So when this is present in the plane, this lone pair is present in the plane, then it will not be conjugated with the pi electron cloud, which is present perpendicular to the plane of this molecule. So this lone pair is not participating in aromaticity. There are two lone pairs present in the heteroatom, that is oxygen. So one of the lone pair is in conjugation with these pi bond. It means one of the lone pair is contributing towards the aromatic sextet. It means 6 pi electron system. So what is happening in this case? This one of the lone pair is contributing towards the aromatic sextet. So what is happening? 4n plus 2 pi electron system is followed. N value is 1. So 6 pi electron system which are completely delocalized. This oxygen is also following sp2 hybridization. Because of that, one of the lone pair is present in the orbital which is unhybridized and which is perpendicular to the plane of hybridized orbital of the oxygen. Because of that, this perpendicular orbital is having lone pair, so it will be involved in the conjugation with the next pi electron system. So what is happening in this case? So there are 3 hybridized orbital of the oxygen which are present in the same plane. These are 3 hybridized orbital. So in this case, these are sp2 hybridized. In this case of oxygen, there is one electron in this, and 2 electrons are present in the one of the hybridized orbital of the oxygen. So this lone pair of electron which is present in this one of the hybridized orbital of the oxygen is present in the plane. So it will not be involved in the conjugation because it is present in the plane. Whereas one p orbital which is perpendicular to the plane of these hybridized orbital, this p orbital is having 2 electrons. This p orbital is having 2 electrons, that is one of the lone pair which is involved in the conjugation. So this lone pair of electron which is present in the perpendicular p orbital, that is unhybridized p orbital, will be involved in the conjugation with the next pi electron system because both are parallel. So this lone pair is contributing towards the aromatic sextet, that is 6 pi electron system, whereas this lone pair, second lone pair, is present in the hybridized orbital which is present in the plane. And you know that electrons which are present in the plane are not involved in conjugation. Similarly, in the case of thiophene, this is thiophene. In this case, there is also 2 lone pairs of electron and 2 pi bond. So the pi electrons which are contributed by the pi bond are 4, and one of the lone pair of this sulfur will be involved in the conjugation with these pi bond. So it means this is following 4n plus 2 pi electron system. N is equal to 1 and there will be 6 pi electron system is present in this molecule. So how 6 pi electrons are present which are involved in the conjugation? Because because one of the lone pair of the sulfur is contributing towards the aromatic sextet. Because of that, this lone pair is present in the perpendicular unhybridized p orbital, so it is involved in the resonance. So next, in the case of this is pyrrole. So what is happening in this case? There are two pi bonds and one lone pair. So this lone pair is also involved in conjugation because it is also following this rule, 4n plus 2 pi rule. How it is following 4n plus 2 pi rule? Because in this case, as you can see, there are three hybridized orbital which are present in the plane and one unhybridized orbital which is perpendicular to the plane. So these are three hybridized orbital. This is one sigma bond, sp2 hybridized. This is one sigma bond found with this carbon, and one sigma bond is found with nitrogen and hydrogen. So this is a third sigma sp2 hybridized orbital. So there are three sigma sp2 hybridized orbital which is formed by this nitrogen, one with this carbon, one with this carbon, and one with this hydrogen. And there is one lone pair is present, and this lone pair will be present in perpendicular to these hybridized orbital. So this lone pair, when we involved in resonance, that is delocalization, because of that this lone pair is contributing towards the sextet, that is a 6 pi electron system. Next is annulenes. Annulenes are completely conjugated polyenes which are consisting of even number of carbon. They are having general formula CH double bond CHN, and this N is having value 1, 2, 3 and so on. So in this case, example like, so first is cyclobutadiene. This is conjugated polyene. So what is happening in this case? How it will be named in the form of annulene? The number of carbon which are present in this cyclobutadiene are 4. So the number of carbon will be represented inside the bracket, and further we will name it as annulene. So what is happening? There are 4 carbon which are present in this cyclobutadiene. So further it will be named as annulene, 4-annulene. Next is benzene. How many number of carbon are there? 6. 6-annulene. Next, this is a cyclooctatetraene. This is also having even number of carbons, so it will be named as annulene. So the number of carbons are 8. 8-annulene.